Hello, welcome to Quiz 7, Hillshade Slope Eatonville. In this scenario, you have just started a GIS Analyst Position for the City of Eatonville, Washington. On your first day, you attend a meeting and are requested to do your part to help secure a new manufacturing plant that will provide over 100 direct and 250 indirect jobs to the Eatonville, Washington community. The mayor and city council request that you identify all of the commercial service, industrial, or vacant parcels that are greater than 1 acre in size within 3,000 linear feet of the city of Eatonville that are situated on little to no slope. That is 0 to 2 degrees, 0 to 2% slope, or 0 to 1.1 degrees. To help you, they have requested one specific deliverable, a possible parcels Eatonville.shape, that is a shapefile, with only the vacant industrial or commercial parcels greater than 1 acres within 300 feet of Eatonville that have little to no slope. That is the scenario that we will follow in this Quiz 7. Feel free to follow along using the directions and the data that you may obtain online, or simply watch as I complete this exercise. There are multiple ways to perform this analysis, and this of course is not a true analysis. It's more of a way to show and practice how to use certain tools within ArcMap. The image on the screen is showing the selected parcels of this completed analysis. This is the point that we're going to end up with at the end of this exercise. This is a previous completion of the work to give a visual of what we're actually looking for. As an example of the layers that we're going to create, this is the city boundary of Eatonville. Have an Eatonville buffer using the 3,000 linear feet. Digital elevation model, DEM, of Eatonville. Hillshade of Eatonville. Slope of Eatonville. Here's a reclass of the Eatonville slope. It's a polygon version of the Eatonville slope. Land use for the parcels within the 3,000 linear foot buffer of Eatonville, and a set of preliminary parcels. Let's get started with the exercise. I have prepared ArcMap, changed my data frame, name, created my directory, my user ID for Quiz 7, my raw data within my directory, and saved my map as start. I've also prepared the other steps that are required when starting ArcMap in GIS classes at UW Tacoma. The first step in this analysis is to determine what data is necessary. In looking at the problem, we're trying to find a shapefile that contains only vacant industrial or commercial parcels within 3,000 feet, linear feet of Eatonville that have little to no slope, that are greater than 1 acre. It appears that we can get away with starting with just 3 pieces of data: parcels for the City of Eatonville, slope for the City of Eatonville. We'll have to create that based on a digital elevation model, however, and an Eatonville, Washington boundary. Therefore, the next step is to collect our necessary data. And we'll start with 1 arcsecond digital elevation model from the national map. The United States Geological Survey, the link is shown right here, is where we will download our digital elevation model to help with this analysis. The first step in this process is to get an idea of what area Eatonville covers, and I've found the easiest way to do so is to search for Eatonville at this advanced viewer page. In this view of Eatonville, the boundary of Eatonville isn't very easily viewed. We'll manipulate the view a little to make it easier to see. First step I like to do is to change the base map. I like to use the light gray canvas. It gets rid of a lot of the erroneous data, and turn that off. I then go to the layer list and turn all layers off. From there, I can turn on what I need to see Eatonville. First, I'll put Eatonville so that it's viewable on the left side. And governmental unit boundaries are usually the most helpful. And from here, if you don't do it often, it's a guessing game as to which ones work best. I'm going to turn off the labels because I know where Eatonville is. And then in terms of features, I'll try county or equivalent. That should work. State, territory, or large scale. Let's try these and see what happens. We'll turn them on. And it didn't help our view yet. Since they did not help, I'll turn them off and try something else. Incorporated place. Eatonville is a city, so this should work. We now have Eatonville showing on our map, which will make this a lot easier when we go to download the digital elevation model. You may wish to take a screenshot of this so you have a reference, or just get an idea that we want to go up to this lake and about equidistant on all sides if we go that distance when we select an area to download from the data download area. Once you've got a good idea of what we're downloading or the extent, click on data download. It's similar in looks, but this is called TNM download, the National Map download. At this point, I'll search for Eatonville, Washington again. Scroll in some and recognize this lake. I can draw an extent box around using this distance, and I should be able to grab the data necessary. I'll choose box point and try to draw my box big but not too big around Eatonville. And I have my box or my extent set. I must now find the digital elevation model information. As noted, we want the digital elevation. I'll choose elevation products. And here is what we're looking for, a 1 arc-second DEM. It's beyond the scope of this analysis or this quiz to talk about the differences between the 1 arc-second, 1/9, 1 meter, etc. We don't need super accurate data. Notice how the clarity between these two descriptions. For our purposes, 1 arc-second will work fine, and we want an arc grid format. From there, we click Find Products, and we're presented with one option, which should make it easy to download. In this case, we'll click the download button and be presented with a zip file that we should save to our raw data folder. I'll save this in my raw data of quiz 7 in my quizzes folder of my current year and quarter directory. Winter 2020 is when I'm making this recording. Save. At this point, I'm done with the national map, so these can be closed, and I will extract my data. Don't normally show extracting, but for this I will. I'm going to use WinZip, but you could very easily, actually I'll use the normal method, extract, open with Windows Explorer. I'm going to click the extract button, extract all. I'm going to delete the last folder. It's in my raw data. Click extract. I can close this window and the data is now in my raw data folder. Notice we went from 0 data to quite a few pieces of information. We only need 1 or 2 of these items for our analysis. I'd like to point out this README file that now comes with the downloaded data. It's very good information. It talks about the data that you've just downloaded, how to cite it, the reference, etc. Not going to go through it now, but just know it's there for your use when necessary. Now that I've extracted the data, I can close that folder, refresh my raw data, and there's several files that ArcMap reads and understands. There's a shapefile that we're not using, and then here's the grid that we'll be using in our analysis. The other 2 layers of data that we'll need are the boundary file for Eatonville, Washington, and the parcel data. Those can be retrieved from the Pierce County Open Data Portal. I'm going to enter that in my search of Google. I'm feeling lucky, and it should go right to the Open Data Portal. And this is where we'll download the data. Notice that there's this reference. I've talked about this a little bit. This will cause problems when we project. However, it's only off by minuscule amounts, and we're not going to worry about the errors that we receive. I'll show you those when we get to the projection of the layers. Keeping this information in mind, we are going to download something that hasn't been used in this class yet, or in our introductory class. We're going to download a file geodatabase, which will look a little bit different, but it'll work for us a little bit better, and we may not have the discrepancy in the projection. We might not get a projection error. Let's find our data. We're looking for parcels, first of all, and instead of searching, I'm just going to I clicked on the parcels data button, and now I have tax parcels with 328,000, which makes sense for Pierce County. I simply click on it, and then there's a download option. And remember, we normally would download a shapefile, but because of that warning, we're going to download the data in what's called a file geodatabase. I save the file to my raw data. Raw data, quiz 7 of my quizzes in my directory. The other piece of data we needed was cities. I'll just type in cities. It's not city annexations, but cities in Pierce County will work. It's a layer of all the different cities. I'm going to download a file geodatabase, save it in my raw data. I'm in raw data. Save. And now that the data is downloaded, I will extract. I can close this browser. In Windows, I'll quickly extract my data. This time I will use WinZip because it's a little bit easier for me. Tax parcels and cities in Pierce County. Refresh my raw data. And I have two pieces of data that contain, one contains the tax parcels and one contains the cities in Pierce County. It's important to note that normally you'd see a folder, but in this case it came in as a file geodatabase, and we did that because of the projection issue. For now, we'll consider this geodatabase where I'm hovering, GDB, as a folder. It's not a folder, but we'll just assume for now it's a folder. It'll be less complicated. We have a folder with tax parcels and we have a folder with cities in Pierce County. And at this point, I don't have any data in my data folder. It's all in my raw data. The most important aspect of working with GIS data is lining up our data. So we'll check, or I will check for you to determine what the data information is. You cannot see properties, but I'm scrolling down to properties. This is in an ED 1983 Harn State Plains South. So tax parcels are in Washington Harn State Plains South. That's perfect. Cancel. I will try to get it so you can see cities in Pierce County, properties, NAD 1983 Harn State Plains South. So two of our layers are in Washington Harn State Plains South. At the beginning of this assignment, I mentioned that we'd be using Harn State Plains South. The last item we need to check is the raster, and this item right here is the raster, the DEM that we have downloaded. I right click, properties, same process, it just looks a little bit different. I scroll until I see the XY coordinate system. In this case, it is Geographic Coordinate System North America 1983, which means that it will not line up with my other data. I'll just click OK and make a mental note that I have to project this raster, very similar to project a shapefile. To get the process moving, I'm going to bring tax parcels, cities, and the raster into my map. When you bring rasters in, it asks if you'd like to create pyramids. We do want to create pyramids. It allows for rapid display at varying resolutions. So we will say yes. However, the first thing we want to do is to make sure we choose the proper resampling technique. I'll click About Pyramids, and it gives us a help document. I'll make it so you can read it. Pyramid resampling defines how the data will be resampled when building the pyramids. Nearest neighbor is used for nominal data or raster data sets with color maps such as land use or pseudo color images. Bilinear is used with continuous data such as satellite imagery or aerial photography. And cubic convolution used in continuous data such as satellite imagery or aerial photography. It is similar to bilinear, however it resamples the data using a larger matrix, which results in a smoother appearance. We will choose bilinear because we are dealing with continuous data. There is it's digital elevation, so we have an elevation. There's no place that doesn't have a stated elevation. We'll use bilinear. In terms of compression, we are going to use LZ77 lossless compression. The values of the cell in the raster will not be changed. We could also use no data compression as well. I click the button, I go to the drop down, choose bilinear, pyramid compression, we'll choose LZ77. We will not check this box, and I'll click yes. And it tells me right away there's a geographic coordinate system warning. This data coming in, the raster, the DEM, has a different coordinate system. Geographic Coordinate System, North America 1983. This reminds us that our data will not line up, and we'll see that in a moment. It appears to line up because we are projecting on the fly. And once the map gets done drawing, we'll move further. Right now, we have our digital elevation model lined up with Pierce County. But we just added data to our data frame. I should clear the projection of our data frame. Right now it's Harn, State Plane South, because that is what the first layer that I brought in had, and it set the projection on the fly. I'm going to clear the projection, click Apply, OK. The raster has moved from the screen because it does not line up. It's in a completely different coordinate system. There's Mount Rainier. Eatonville is somewhere in this area. The process now is to project our layers into our data folder. 2 will be a project because it is vector data, polygons and polygons for tax parcels in cities in Pierce County. And then a project raster, which is a new tool for this quiz and Lab 7. We will project raster. We'll project this layer into our data. We cannot just drag, as we have with shapefiles from a geodatabase into a data. It will not work. It may look like it works if I could just click and drag the data, but it should not be done because geodatabases are not the same as folders. So we'll use a different process. We'll simply export the data for those that do not have, for those that have the correct coordinate system. These actually don't need to be projected. Now that I think about it, they have the right projection. I just need to export them into the data folder. I'll start with the raster first because the other two are rather easy. In the projections and transformation folder of the data management tools, there's a raster. I'll open the raster with the plus, make it a minus, and project raster. I'll make it fit the screen from here, and now that they're in the map, I can simply click the down arrow instead of searching for it using the folder button. I'll grab my raster. It tells me that it does have GCS North America 1983. I'm going to create a name for this raster. Down here. We'll call this raster project, or PROJ for short. The output coordinate system is Washington State Plane Harn South, US feet. It will apply a geographic transformation. The resampling technique, I want to click in the nearest and then choose bilinear. This bilinear interpolation calculates the value of each pixel, etc., etc. It is suitable for continuous data. That is the choice that we're going to use. And we'll keep the X and the Y cell size as they are. The dialog popped up, completed successfully. Click close, open my data, and it should be there. And let's verify that it has the correct projection. Properties, XY, NAD 1983, State Plane, Harn South. Perfect. I can now remove the old raster, and let's verify that the data is the same. We'll right click, Properties, NAD 1983, State Plane, Harn South. NAD 1983, State Plane, Harn South. These are still not in my data folder yet, and I can notice that by clicking on the List by Source button. Right now I have data in my raw data, the vectors, polygons, and I have data in my data folder. These two need to get into my data folder. For that, I right click, Data, Export Data, and send it to my data quiz 7. I will call this Cities in Pierce. The name doesn't really matter. And notice that it says File and Personal Geodatabase Feature Classes. I'm going to change that to Shapefile because we are now using a shapefile. Yes, I want it in the map. And now I'll try Tax Parcels, Data, Export Data, send it to Data Quiz 7. Notice that Cities in Pierce is in there. We'll call this Tax Parcels Pierce. The name again doesn't matter, it just will help me remember it. This will take a minute because it's large. The process completes, and yes, I want to add it as a layer. Now, my tax parcels and cities are within my data. I can remove the old raw data. Don't be alarmed that there's two lines for the data. Normally, we would be concerned that there are two different lines, but if we look at them, they are exactly the same. 311 directory, quizzes, quiz 7, user ID, quiz 7, data, quiz 7. Rasters and tables often in this version of ArcMap have an additional data line showing that it's coming from the same folder, but it appears that it might be a different folder because there's two different lines. We would take caution if there were shapefiles in a different line, but for rasters or tables, they will have a different line or directory as this does. I'll go back to list by drawing order and zoom to one of the layers, and all three should be lined up. I have tax parcels. Cities in Pierce isn't showing because it's hidden behind tax parcels. I'll move that up. They are different, very similar colors, I should say. For now, I will just assign random colors that make it easy to see. We'll tap blue. We should be able to see the cities now, and the tax parcels. There's no real need to colorize that one or symbolize because of all the borders. The light gray is making this just a bunch of border colors. But we can see now that everything that does line up, and we're ready to proceed. In about 30 minutes, we were able to find the data that we need, get it projected, and into our data folder. This will conclude the first video for Quiz 7. The next video will focus on narrowing down our data and coming up with the final answer for the project. If you have any questions, feel free to email me. You may comment on this video, like it, subscribe to my YouTube page to get more videos, to see more videos as they are produced. Thank you for watching. I'll see you in Quiz 7 Part 2.